Let's trace this algorithm that is a classic binary search. Mid equals 0, so we reflect that here on our scratch paper. Numbers is an array, and these elements are in index positions 0 through whatever the length is, minus 1. Found is a Boolean variable initialized to the value false. Key is 65, which doesn't have a column here. Apparently it doesn't change in this algorithm, so I didn't make a column for it. Low is 0, and high is whatever numbers.length minus 1 is. The length of this is 9. 0 through 8 makes 9 elements. 9 minus 1 is 8, so that's that. Okay, we begin traversing this while loop. Is low less than or equal to high? Yes, it is. 0 is less than or equal to 8. Is not found equal to true? Well, found itself is false, and the not of a false is true. So we have a true ANDed with a true. Therefore, we do go through the loop. Mid is now equal to whatever low plus high is divided by 2. Low plus high. 8 divided by 2 is 4. That 4 overwrites the initial 0. And now we analyze the if-else-if statement. Is key greater than numbers mid? Well, key is 65. Numbers mid, that's a little tricky. Mid itself is 4, so since that's in square brackets, that's telling us to go to index position 4 of the array numbers. Well, index position 4 is a 60. Notice that index position 4 is really the 5th element of the array if you were to count 1, 2, 3, 4, 5. But it's in position 4. Okay, anyway, 65 is greater than 60. So this executes. Mid plus 1 is simplifies to 5. That 5 is placed in the variable low and overwrites the 0. And nothing else in this else if else executes because all of this was true. And we hit this curly brace, which a good programmer might document as end of while loop so that people know that it matches up with the top of this while loop. Okay, all of that for one iteration of the while loop. Guess what we just did? In this algorithm, the number that we're looking for, 65, we've just narrowed it down that it's between the index positions 5 and 8. We know that 65 is somewhere in this portion of the original array, if it's in there at all. And if it's not, which as a human being I can see that it's not, this algorithm will eventually print out that it was not found. But we're not there yet, so we have to continue tracing. Okay, so we iterate this loop again. Hopefully the control expression will evaluate to true. Let's check that. Is low less than or equal to high? Yes, 5 is less than or equal to 8. Is not found equal to true? Yes. So we go through the loop again. The new mid is whatever low plus high divided by 2 is. Well, low plus high right now is an odd number, 13. And 13 divided by 2 in most people's mind is 6.5. But because of integer division and the fact that we use a forward slash there between two integers, two whole numbers, the 0.5 gets chopped off. So to carefully trace this algorithm, mid is the value 6 at this point because the 0.5 chops off and we do not round. So cross this 4 out and make it a 6. And now we analyze the if-else statement. Is key greater than numbers mid? Is 65 greater than numbers mid? Well, since mid is 6, that takes us to index position 6 of the array, which is 91, and this is false. 65 is not greater than 91. So we analyze and evaluate this control expression. Is 65 less than 91? Yes, it is. So let's execute this part of the else if. High equals mid minus 1. Instead of plus 1, minus 1. Mid is currently 6, and 6 minus 1 is 5. So that 5 gets assigned into the variable high, overwriting the 8 that used to be there. And now we travel back up to the top of the while loop for another go around. What do we have at this point on our hands? We know that the key value, 65, that we're looking for, must be between index positions 5 and 6. So it's somewhere in here, if it is in there at all. Now really it's between 60 and 93. We're just not sure where in that range it's found, if it's there. We know it's not there, again, I emphasize, but we have to trace this algorithm to see how the computer determines whether it's there or not. I'm going to stop here. It's your job as homework to trace the rest of this algorithm and circle your final answers, whatever number low ends up being, whatever number high ends up being, and whatever number mid ends up being. And then ultimately you have to tell me whether this part of this latter if statement executes or if the else clause executes. And if so, what numbers print out on the screen. And then after you're done with number 2, you'll have to trace that same algorithm again, but using this array as the array that you're searching for, and the value 32 is the key instead of 65. Good luck.